In this lesson, we'll talk about object lifetime. When you create a new instance of objects within your project, that object will only be around for a limited amount of time. As long as your application keeps a reference to that object and continues to use the object will stay alive. However, if you were to close the application, or if in your code the reference to that object goes out of scope, then the .NET framework will flag that object to be removed from memory, and a special application called a garbage collector will come around and remove that object from your computer's memory and basically clean up after your program. And I've already detailed all of that in the lesson text for lesson 14. And I made the analogy of an object having a lifespan, just like all living things have a lifespan. You have a birth, and eventually you have a death. Within object-oriented programming, those are important events in the life of an object, and you can write code that executes whenever those events occur. So let's create a new project. And we'll call it Lesson 14 under the Begin 1 subdirectory of my C drive. And to the project, let's add a class. We'll call this class car. And in the car, let's create some private fields. And if we were ambitious, I could go ahead and create some public and private methods and some public properties as well. But I won't do that just because we have a real simple need for this class. When a new instance of our car class is created, we can write special code that's called a constructor. And that constructor can set some of the initial values for our private fields. It can create a connection to a database or open up a file on our hard drive, or any other work that needs to occur before the car class is really usable by our application. To create a constructor, all we need to do is public sub new, and then we can just simply write some code in here. For example, make, clear that out, model, we can clear that, elapsed mileage. And these would all be legitimate uses of a constructor. Maybe instead we want to use the word default, or set it to some other value. And this would be legitimate as well. We could here create a database connection, or open a file, or anything that our application needs, or the car class needs in order to operate correctly, just like I said before. Now there's also a way to override our constructor by creating another method signature for the public sub new. So what we can do here is new, and then we can set make equal to make, model equal to model, and elapsed mileage equal to elapsed mileage. And so now, whatever application uses my car class in the future, they're going to have their choice of constructors. So let's go ahead in my form that was automatically created for me when I created a new project. In the button 1 click event, let's create a new instance of the car class. Dim my car as car. My car equals new car. And notice now that there are two constructors. The first one, I can simply just create an instance there, and the values for the make and model will be default. Or I could do my car2 as car. My car equals new car. And then pass in $200,000 miles. And now I've just set the values of the make, model, and elapsed mileage by default whenever my new car object is created. In a sense, creating your objects in this manner is really shorthand for the user of your objects. Because what I could do is create 3 public properties, like so, and I have a public property make, public property model, and public property elapsed mileage. Then what my user would be required to do is my car dot make equals Oldsmobile. My car dot model equals Cutlass, and then my car dot elapsed mileage equals. So I've just reduced what it would take to do in 5 lines of code and did it in 2 lines of code and achieved the same effects. Plus I get the benefit that the user is prompted to fill out all this information before maybe calling a method on the car object, which we don't have right now, but maybe a save method where it would require to have all 3 values populated. Doing it this way, I might actually forget the elapsed mileage and then cause a problem to happen within my program. So there's a couple different benefits from using overloaded constructors and constructors that have a method signature with multiple values passed into it in order to initialize those values in the object itself as it's created. So let's do this. I'm going to go ahead and change this to actually 2. We'll go to our car class. And we'll do almost the exact same thing here. And we'll use this in just a moment as we execute our application. Now, just as objects have a birth, they also have a death. And the way that you write code for the death of an object is to use the finalize method. And so what I'm going to do is put my cursor at the very bottom of this class, and then make sure car is selected in the class name, and the method name I'm going to select finalize, and it's going to create the basic structure for the public sub or protected sub finalize. Just in case this object was derived from another object, which you don't know about yet because we haven't talked about, but if this were to use inherit from a different object, then calling myBase.finalize would also call the finalize for any of its parent objects. Don't worry about that. That's not an important concept today. We'll talk about that in the future and as we continue to learn more about object-oriented programming. But for right now, what we can do with the finalize method is capture an event that occurs right before the garbage collector destroys our object and takes it out of memory. So what we can do here, for example, is save the values of car into the database, or we can close any files that we have open, or essentially anything that we need to do to clean up after our object once it's finished being used. Now, like I wrote in the lesson text, typically you're not going to have to worry about this. If you're using some external resource like a database, like files, like maybe some handles into the Windows API, and I listed a couple of other examples of where this would be helpful, then yes, you might need a finalized method. This is more to just round out your understanding of the lifetime of an object. So what we'll do here is just put a message box and just pop it open whenever the finalize method actually gets called by the .NET framework, and that message is passed to our car object. So let's review what our code is going to do when we run it in just a moment. First, we're going to create an instance of my car as car, and then create a new instance of it using the default constructor, and then we're going to create a second object called myCar2 as car, and then use the overrided constructor for the car. So we would expect to see two message boxes as we click the button on the form. Then we'd also expect to see a message box whenever the object goes out of scope. So let's run our application and see when that occurs. It called the default constructor, and then it called the overloaded constructor. And we could wait and wait and wait, and eventually the garbage collector would come around and realize that we no longer need those two car objects because their references have gone out of scope now that the button one click event has finished its task. And so we could either wait, or we can kind of speed up the process by just closing the application. When we close the application, obviously that's a signal to the garbage collector that we need to take a lot of stuff out of memory, so it's going to expedite the process. And notice what happens in the process. We get that called finalize message box to pop up. And it didn't wait for us to click it because the garbage collector was anxious to get rid of everything out of memory. So you can see that using the finalize method is what's referred to as a non-deterministic destructor, because we can't determine the exact moment in time when our finalize method will get called. Therefore, you shouldn't rely on it for something that's very important to you. You'll need to figure out some other way to accomplish whatever you're trying to do. It's only useful when it does not have to save the values of the car object into the database or close any files that the car object has open at a specific point in time. If you need a more deterministic destructor, you can use the dispose method, which I alluded to briefly in the lesson text for lesson 14. It's a more advanced idea, so I'm not covering it in this lesson, but it is available to you if you need to do something like that. But again, many times you're not even going to need to use a destructor within your classes unless you're managing some sort of resource. So I think we've covered the birth, life, and death of objects. We've talked about constructors and overriding constructors, and then also destructors using the finalize method. As always, I strongly encourage you to go through the lesson text, go through all the lesson steps, including the extended readings, filling out the definitions and the lesson questions, and probably one of the best things that you can do to get your hands dirty is to go through the actual exercise and then watch the solution for the exercise. So, thank you. Hope this was helpful.